Hello, welcome to lecture on ratio test, root test. Um, Theorem of ratio test. So in this lecture, if we have a sequence from k equal to 1 up to infinity of a of k with non-zero terms, if we take the limit, the absolute value of the limit, and we get L, if L is less than 1, the series converges. If L is equal to 1, the series does not provide information of whether it converges or diverges. If L is greater than 1, the series diverges. If the limit of a of n of the series over a of n plus 1 over a of n is equal to infinity, the series diverges. Okay, so this is the example. We are going to use the ratio test here. So first, to use the ratio test for the first problem, I'm going to say a of n of the first problem here, a of n is going to be equals to n over 4 raised to the power of n. Then a of n plus 1 it's going to be equals to n plus 1 over 4 raised to the power of n plus 1. And then now we take the limit of that as n goes to infinity of a of n plus 1 over a of n. So then we get n plus 1 over 4 raised to the power of n plus 1 times 4 raised to the power of n plus 4 raised to the power of n over n. And that gives you 1/4. So 1/4 is less than 1. That means the series converges. Okay, now let's examine this series. So here my a of n at this point is going to be equal to 2 raised to the power of n, n over n. And then a of n plus 1 is equals to 2 raised to the power of n plus 1 over n plus 1. And then we take the limit as n goes to infinity. So we get 2 raised to the power of n times 2 divided by n plus 1 times n over 2 raised to the power of n. 2 raised to the power of n, 2 raised to the power of n cancels out. This is here we take the absolute value. And then since it's positive, so the absolute value won't have that much effect. So then we have limit as n goes to infinity of 2n over n plus 1. Then we get 2. So 2 is greater than 1. So that means this series here diverges. Okay. So let's take the second series. My a of n in the second series, my a of n, it's going to be equals to 3n plus 1 over n squared. And then a of n plus 1, it's going to be equals to 3n plus 4 over n plus 1 squared. Then we take the limit as n goes to infinity of this. So we're going to get 3n plus 4 over n plus 1 squared times n squared over 3n plus 3n plus 1. So we take the absolute value, but since everything is positive, so it won't have that much effect. So limit as n goes to infinity of 3n squared plus 4n squared divided by 3n cubed. Sorry, this is 3n cubed. 3n cubed plus 7n squared plus 5n plus 1. So when we take the limit of that, we will get 1. So 1 does not give me any information, but I can use another test to examine whether the series converges. Okay, the last one, we are going to our a of n here is going to be equals to 1 over n factorial. A of n plus 1 would be equals to 1 over n plus 1 factorial, then limit as n goes to infinity of 1 over n plus 1 factorial times n factorial, that we should get limit as n goes to infinity over n plus 1, that is equal to 0. So this also converges. Okay, so we want to determine using the ratio test whether the series above, whether this series converges or diverges. So here, what is my a of n? My a of n, it's equals to n factorial over n raised to the power of n, and then a of n plus 1 is going to be equals to n plus 1 factorial over n plus 1 raised to the power of n plus 1. And then now we're going to find the limit. So limit as n goes to infinity of this quantity. So n plus 1 is going to be n plus 1 times n factorial over n plus 1 n plus sorry so n plus 1 times n plus 1 over n raised to the power of n times n over n factorial. So the n factorial cancels out, and this and that cancels out. So then we have limit as n goes to infinity of n raised to the power of n over n plus 1 raised to the power of n, and then that is going to be limit as n goes to infinity of 1 over 1 plus 1 over n raised to the power of n. This is equal to 1 over e. This one here, the limit of that as n goes to infinity is equal to e. So this also converges. So using the ratio test to determine whether the series, this is similar to what we just discussed a minute ago. So we may not do everything in details at this point, but when we set up the problem, we should be getting at the end limit as n goes to infinity of n plus 1 over 10, and that is going to be infinity, so it diverges. Okay. So to use what is the root test? The root test works well for a series of non-zero terms whose n terms involve n's power. So if we have a series like this, and then we take the limit, with that limit we take also the nth root. This is nth root here, and then we get L. So if we get L from that nth root, if L is less than 1, then the series converges. If L is greater than 1, so the series diverges. If L is equal to 1, then we say no information provided. So let's test it here. So we say limit as n goes to infinity of, so we take the absolute value of these, so it's going to be e over k raised to the power of n, and this is the nth root. So then it's going to be limit as n goes to infinity of e over k, or e over n, sorry, this should be n because we are using n here, e over n, so that this goes to 0. It goes to 0, so it converges. Okay, so same thing here. We're going to take limit as n goes to infinity of this quantity here, 8n plus 3 over 5n minus 2. This is raised to the power of n, and then we take the nth root. So then we say limit as n goes to infinity of the quantity 8n plus 3 over 5n minus 2. So then we get 8 over 5, which is greater than 1. So that means this one here diverges. It diverges. That's all. Thank you for listening.